In this recording, we're going to look to shift vertically our sinusoidal graphs. That word sinusoidal sounds pretty complicated. Basically, it just means a sine or a cosine graph, kind of like we saw here, this wave function, okay? And it could either be a sine graph or a cosine graph. In our last video, we looked at the effect of this a, okay, as it stretched out our function. And today we're going to look at the value of c and what that does to a function. And from your other experience with other functions, I think you already have a pretty good sense of what happens when we add 3 outside of a function. Put a constant on here, and it just shifts that function up, right? So we're going to take this graph, and all its y values are going to be shifted up 3 units. Okay, so what that looks like is you're just going to take this point here, which is on the x-axis, and it's going to go up 3 points, up 3 units, so right there. And this point here is going to go up 3 units. So do that for all the points. In other words, there should be 1, 2, 3, 4, 5, 6, 7, 8, 9 points that you shift up. Then draw a smooth curve between them, and play the recording when you're ready. Okay, so hopefully you took the time to make your graph. We should always label our graph. Okay. Now we have a function that has 2 different transformations, okay? Think back to what the effect of the 2 is on our graph. Hopefully you realize that's a vertical stretch by a scale factor of 2. And then we have this 1. Well, obviously we know the order of operations says you have to stretch it and then shift it, but it's going to be a whole lot easier if first we graph this line y equals 1. Now here it says using your calculator. Hey, that is for people that don't know what they're doing. The first thing I'm going to have us do is first shift our whole x-axis up 1 unit. Okay, so if you see that +1, that means our midline is shifted from the x-axis up 1 unit. So you can go ahead and just dot in that midline right here. All right, and now we're going to pretend that's our new axes. So we'll think about, okay, what does cosine graph usually look like? Okay, think about a cosine graph. Usually starts up at the amplitude and makes this shape, right? So this cosine is going to start 2 above the midline, right? 2 units. So it's 2 above this dotted blue line. And it's going to end up, after 1 full cycle, after 2 pi, it's going to end up back 2 units above the dotted blue line. In the meantime, it's going to hit these spots, right? 1, 2, 3, 4. It's going to hit all those spots. So, all right, it's going to make that graph. All right, and that's 1 cycle. And then to complete for this domain between -2 pi and 2 pi, we'll just repeat that process. Okay, so over here it says, okay, what is the equation of the horizontal line that this curve rises and falls 2 units above? Well, this is the line. Our amplitude is still 1. It still goes 2 units above, 2 units below. But notice how the range has shifted up by 1, okay? So the line that this curve falls 2 units above and below is y equals 1. That's called our midline. And no coincidence, that 1 here corresponds to that +1 here. Maybe you'd like to draw a line on your little arrow on your notes. And then our range, our normal range of cosine would be, for this graph, would be between -1 and 1. Okay. Once we stretch it vertically, now it would be between -2 and 2, because everything would be stretched out by a scale factor of 2. But our graph is not only stretched vertically, it's shifted up 1. So both of those get a 1 added onto them. So that should take it between -1, and 3. So check yourself. Is that, in fact, the range of this graph? Does it go between -1 and 3 in the y direction? Okay. Seems like it does. And again, we can see that on the graph, but we can also reason about it, taking our original cosines, range, doubling the min and the max, and then adding 1 here because we shifted up the function. On this next page, it gives you some vocabulary here. C is called the midline or average value. In other words, if I want to find that midline, I can find the average. So let's go back to our other one. If I want to find the midline from a graph, I can take the average of 3 and -1. So I can do 3 plus a -1, average it. In other words, divide by 2. So that's 2 over 2, right? Equals 1. That's the midline. So it's the average between the max and the min of the function. That's going to be handy later on. And then the height that the sinusoidal curve rises and falls above the midline is A, the amplitude. Okay, so back to our other graph, the amount that it goes above and below the midline. So it's 2 units here above, and then 2 units here below. And it's always going to be the same amount that it goes above and below, and that's called the amplitude. Okay. It's never negative, by the way. It's always the absolute value of whatever A is. Okay, so I'd like you to make a couple graphs here. I'd like you to make the graph of 4 times the sine of x minus 2. Again, I would recommend plotting the line -2 here first, thinking about what your original graph of sine looks like. Okay, so hopefully you know the sine graph starts at the origin, makes that shape. And our cosine graph starts at the amplitude, makes that shape. Okay. So for this particular function, we're going to start at y equals -2, and you're going to rise and fall 4 units above the midline of -2. So why don't you give that one a shot? Get as far as you can. Play the recording when you're ready. Okay, I'll go through this one for you. Okay, so there's our graph of the first function. I need to know the basic pattern of sine, that it starts on the midline and goes up. And I needed to have started my midline at y equals -2. And then I just needed to go up 4 units each time because our amplitude here is a 4. All right, so our range can be found 2 ways. We can just count and look at our range to be -6 up to +2. And hopefully also I can realize, hey, it's really just starting at -2 and doing plus or minus 4, right? I'm starting at -2, I'm going up 4 and down 4, and that's how I can also get this number. That's going to be handy later. All right, so let's grab a different color here and have you graph this function. Notice that our cosine function has a negative A value. So that means instead of starting up at the amplitude, it's going to start down 2 units from where the midline is. So get as far as you can with this one, then play the recording when you're ready. Okay, so hopefully you made this graph with a midline of 3. Then for -2 cosine, cosine normally starts up at the amplitude, but it's going to start down 2 units because it's not only stretched, but it's vertically reflected in the midline. So we're going to go there, back to our midline, up, and that's the pattern it's going to make. Okay, so figure out the range and then play the recording when you're ready. Okay, so hopefully you figured out for the range. It starts out at 1 and it goes all the way up as far as 5. It goes between 1 and 5. Square brackets because it's including those values. Also, we could have gotten this from starting with 3, our midline, and doing plus or minus 2. Okay, so 3 minus 2 is 1. 3 plus 2 is 5. Okay. Our final task here is just to take 3 functions without graphing them and determine the range of them. Of course, you could put these into a graphing calculator, but are you really going to want to do that for 25 sine x plus 35? It's got to be an easier way. So based on your understanding of the work we did here, why don't you try to figure out the range for each one of these, starting with your midline and figuring out, okay, how much below that and how much above that do we go? Therefore, what's the range? Play the recording to check your answers. Okay, so for this first one, 4 plus or minus 7 gives us -3 to 11. The next one, we start out at 2, and we're going above by 5 and below by 5. That's going to get us to -3 to 7. And the final one, you're going to start at 35. It's our midline. You're going above that 25 and below that 25. That's going to take us between 10 and 60. I'm going to leave question 5 here for your quiz. If you're stumped on this one, I would encourage you to draw in the midline here and see if that can help you figure out where the midline is based on the 2 points that are given. And then based on your midline, see if you can figure out how much it went above and below that midline. And put those answers into your quiz. Thanks for watching.